Module 1: Origins, Pathways, and Consequences of Environmental Pollution. Introduction. Welcome to this course on environmental pollution management. Our planet is facing unprecedented environmental challenges. From industrial emissions to agricultural runoff, from plastic waste to radioactive contamination, the way humans interact with the environment has left lasting marks. If society is going to effectively manage pollution, we must understand the physical, chemical, and biological processes that govern how pollutants behave in air, water, and soil. This first module introduces you to the origins of pollution, the pathways pollutants take once released, and the consequences they create for ecosystems, human health, and the global environment. 1.1 Understanding pollution. Pollution occurs when substances or energy released into the environment exceed the natural system's ability to absorb, neutralize, or recycle them without harm. While some pollutants occur naturally, such as volcanic gases or forest fire smoke, the vast majority of today's environmental problems arise from anthropogenic sources, that is, human activities. Pollution can be broadly categorized into air pollution, water pollution, soil contamination, noise pollution, solid and hazardous waste pollution, radioactive contamination. Each of these has unique sources, pathways, and impacts, which we will explore throughout this module. 1.2 Sources and origins of pollutants. Air pollution. Air pollution is one of the most visible forms of contamination. It originates from sources such as burning of fossil fuels in transport, power generation, and industry. Agricultural activities releasing methane and ammonia. Domestic heating and cooking using wood or coal. Industrial processes releasing dust, chemicals, and toxic gases. Water pollution. Water bodies are polluted through discharge of untreated sewage. Industrial effluents containing chemicals, heavy metals, or oils. Agricultural runoff carrying pesticides and fertilizers. Accidental spills, such as oil spills in oceans. Soil pollution. Soil contamination arises from excessive use of fertilizers and pesticides. Improper disposal of solid and hazardous waste. Industrial leaks and spills that seep into the ground. Deposition of airborne pollutants that settle into the soil. Noise pollution. Noise is an often overlooked pollutant but has severe health impacts. Sources include road traffic, railways, and airports. Industrial machinery. Urban construction. Loudspeakers and recreational activities. Solid and hazardous waste. Everyday human activities generate massive quantities of solid waste. Hazardous waste, however, pose a special threat as they may be toxic, corrosive, flammable, or radioactive. Sources include domestic and municipal waste, industrial byproducts, biomedical and laboratory waste, mining residues, radioactive contamination. Radioactivity has beneficial applications in medicine, energy, and research. However, if not managed properly, radioactive waste from nuclear plants, laboratories, and hospitals can contaminate air, water, and soil for decades, sometimes centuries. 1.3 Pathways of pollution. Once pollutants are released, they rarely remain where they were produced. Instead, they follow complex pathways influenced by natural processes. Air pollutants may disperse with winds, settle on land or water, or react chemically to form secondary pollutants such as smog. Water pollutants travel downstream, infiltrate groundwater, or accumulate in aquatic organisms, entering the food chain. Soil contaminants may leach into groundwater, volatilize into air, or bioaccumulate in crops. Noise spreads through vibrations in the air or ground, affecting both humans and animals. Radioactive substances may migrate through water and soil or be inhaled or ingested, causing long-term exposure. Understanding these pathways is crucial because pollution rarely affects only the immediate location, it spreads and magnifies through interconnected systems. 1.4 Consequences of pollution on human health. Pollution is directly linked to diseases such as respiratory illness, cardiovascular problems, cancers, neurological disorders, and hearing loss. For example, prolonged exposure to fine particulate matter in the air can shorten life expectancy, while contaminated water remains a leading cause of gastrointestinal diseases worldwide. On ecosystems. Airborne sulfur and nitrogen compounds contribute to acid rain, which damages forests, soils, and aquatic life. Water pollution causes eutrophication, where excessive nutrients lead to algal blooms that deplete oxygen, killing fish and other aquatic organisms. Soil contamination reduces fertility, disrupts microbial communities, and weakens food security. On climate and global systems. Certain air pollutants, such as carbon dioxide and methane, are greenhouse gases driving climate change. Black carbon, or soot, reduces ice reflectivity, accelerating glacial melting. The long-term effects include rising sea levels, extreme weather events, and disruptions to agriculture. On social and economic systems. Pollution imposes financial costs through healthcare, cleanup operations, and loss of productivity. It can also fuel social inequities, as poorer communities often live closer to polluted sites and bear a disproportionate share of the impacts. In this module, we have explored the origins, pathways, and consequences of pollution across air, water, soil, noise, solid waste, hazardous waste, and radioactive contamination. You should now recognize that pollution is not simply a local issue, it is interconnected, cumulative, and often global in scale. This understanding forms the foundation for Module 2, where we will examine how pollution can be controlled, prevented, and managed using modern technology and sustainable practices.